Hi, my name is Ryan, and I am a math tutor at the Digital Learning and Academic Support Center here at Baton Rouge Community College. In today's video, we're going to learn about the remainder theorem using synthetic division. Hi, so today, as we said, is going to be on the remainder theorem in synthetic division. And this video assumes that you already know synthetic division, but we're still going to do a few examples to lead to the remainder theorem. It's a very important theorem, and we're going to see why during the course of this presentation. So the example that we have is a polynomial function f of x equals 2x cubed minus 3x squared minus 11x plus 6. And we're going to try the numbers 1, 2, and minus 2 with synthetic division. So we set it up with our numbers for our coefficients 2 minus 3 minus 11 and 6 for each number. And we're going to do a synthetic division. We went ahead and set that up. So for 1 times 2 is 2, minus 3 and 2 is minus 1. 1 times minus 1 is minus 1. When you add those up, it gives you minus 12. 1 times minus 12 is minus 12. The answer here is minus 6. And this is a remainder. Now, the overall idea is to possibly look for something that gives you a remainder of 0 so that we can use that as a root of the function to do more things. But today is on the remainder theorem, so we're interested in actual remainders. So now we're going to do it with 2 and the same function and see what our remainder is. So 2 times 2 is 4. 4 minus 3 is 1 times 2 is 2. That's minus 9. When you add those up, minus 18. That gives us minus 12. So now we're going to do minus 2. And notice that 1 and 2 gave us negative numbers. Let's see if minus 2, I'm going to draw a line here just to separate this right here, a big line. Let's see if minus 2 gives us a positive number as we expect. So that's just a little strategy to see where you're going with things. So we bring our 2 down. Minus 2 times 2 is minus 4. I owe 3, I owe 4. That's minus 7. Minus 2 times 7 is 14. That gives us minus 3. Minus 3 times minus 2 is 6. That adds up to 12. So our remainder is 12 with minus 6. With minus 2. So we have here 3 examples, right? And of numbers that we get. So now we're going to do the remainder theorem. And the remainder theorem says that with synthetic division, your remainder is actually f of that number. You see this equation here, 2x cubed minus 3x squared minus 11x plus 6. If I start plugging in numbers for x, I'm going to be doing some heavy calculations really quick. So we're doing here an example, f of minus 2. If I plug in minus 2 everywhere that there is an x in this equation to find f of minus 2, I end up with f of minus 2 is 2 times minus 2 cubed minus 3 times minus 2, there's a square here, minus 11 times minus 2 plus 6. And if I do that calculation, I'm going to end up with a 12. But that's going to be some really big numbers that I'm adding and subtracting. So that's the value of the remainder theorem with synthetic division. With synthetic division, it's faster and you do less mistakes and it's more elegant. And that's what you want in math. And we're going to do an example, but I just want to do a shout out to Professor Green at BRCC because this is his favorite theorem in all of college algebra. So now we're going to do an actual problem. Using the remainder theorem in synthetic division, find f of minus 4 for this equation here, 3x cubed plus 4x squared minus 5x plus 3. And we anticipate, because that's a 4 or minus 4, that we're going to be dealing with even bigger numbers than what we had before. So I'm copying the coefficients down, and I'm setting it up, right? We're going to bring that 3 down for starters. And now we're going to do minus 4 times 3, minus 12, added to 4, that's minus 8. Minus 4 times minus 8 is 32. I take away 5, I'm at 27. Now 27 times 4, I can do that here on the side. That's 28. That's 4 times 2 is 8, 10. And I have a negative 4, so that's minus 108. You take away 3 from that minus, and you're at minus 105. So you see here that if I had plugged in a minus 4 and cubed it, a minus 4 and squared it, a minus 4 and x'd it, multiplied by those coefficients in front, and added it, I would have ended up with minus 105. But thanks to this remainder theorem, I did this a lot faster again, no less chance of a mistake, and a lot more elegant. Thank you very much. This session again was on using synthetic division to do f of x, right, with the remainder.